Hello everyone, welcome back to Tux Writers. In previous video we had an overview on the compilation process in Linux. So in this one we want to see it in action by compiling and using GNU Scientific Library. So GNU Scientific Library, or in abbreviation form GSL. So let's search for that. We say GSL, GNU. Yeah, GNU Scientific Library. Yeah, this one. So this is, maybe the simplest form of compiling a library because, this is a big library, but I think usage is pretty simple in comparison to the features that it provides. You can see that it, different fields or different functions that this library provides. This is part of GNU project. As you see that the project is hosted in the gnu.org website, and you can see that it has different functionality, very similar to, let's say, SciPy, but in C or C++. So if you want to convert a Python code or a MATLAB code to C, C++, this is indeed a great library. But what we want to do is we want to download it and then compile and use it. So let's go to that. But before diving into the process, I want to say that this is indeed a library. And it means that we have to write programs like C or C++ program and take advantage of this inside our source code, and then in the compilation process we have to link our program with this library, and this is indeed what we want to do in this video. So let's go for that. It says that for downloading GSL I go to the main GNU FTP site, and you can see that it has versions from 2002 to 2021. That's nice. So yeah, this is indeed a project that they are continuously developing, and it's not obsolete. So yeah, and it goes to the download folder here. That's cool. So let's extract that. Let's extract the source code. So this is into the source tarball. And we have already discussed how to extract this kind of stuff. So it is indeed in a GZ format, GZ compression, and we want to extract it. We want to see the files, and we say GSL version 2.7. And that's it. If we go here, it was indeed better if I extracted that somewhere else. So yeah, instead of extracting it here, let me remove it. Sorry, I removed the whole directory with this. Let me zoom it with this switch. So I go to my home folder, and then I create a directory here, GSL, and then inside GSL, inside GSL, I copy the file in my download folder, GSL here, and then I ask it to extract everything here. So indeed here I have a GSL folder. Let me show you in file browser. That is indeed here, GSL, and this is a directory. And here we have to go for compiling that. In order to do that, I think it has a file called install probably that is indeed maybe something like an instruction, and it tells you that in order to compile it you need to this works with Make, very similar to the previous video. Now you know how it works. But before going for Make, because Make works with with a compiler, with libraries that are installed in a user system, we have to configure the Make file. So very similar to CMake. Here we need to configure or build first, and then call it by the Make command. This file indeed, I think, yeah, explores different available options, but I think this is pretty straightforward, and it says, yeah, you can choose different compilers. We don't want to go for that. So let me show you how it works. So it works like this. You have to, we have to run this command, configure, and this is an executable in the current directory, so it will be like this. And if I press enter, it starts to find different, libraries, required libraries, compilers, and this sort of stuff. But one of the most useful, let's say, switches here is prefix. This is something you should always, care about, and always modify it in a way that, yeah, this isn't an installation location. Let me tell you first that this is indeed very similar to other operating systems. You tell it in the end where to install the compiled library or compiled binaries. The default location is usually in the system directories, like the path as the Linux usually looks for headers, for libraries, for binaries, this kind of stuff. But I want to change it to, for example, I'm not sure if it accepts this, so I write like this. Oh, it is Tux Writers, and inside GSL I say GSL install. Why not? So this is a new GSL install, and yeah, let's see what happens. So this is indeed, I tell it somehow that in the end, when I ask it to install things for me, please install the output here. And this is pretty important. In all the compilation things we do in the future, you will see that I always specify this. So let's see what happens. If there is some error, it will report. In the end, you see that it goes through finding different compilers, finding required libraries, this kind of stuff, and yes, it means that, yeah, they are available. And in the end, if one of the crucial ones is missing, it complains about that. So now the configure is finished. You saw that it was so simple. I just changed the prefix, and now it's the time to call make. Let's go for that. And it starts to compile it. You see the output on the screen. It may take a while, so we have to wait. Generally, these kind of make building processes take quite long, so let's be patient a bit. Okay, so now the build process is over. Yeah, it was quite a big library, so it took a while, and yeah, this is the usual, very normal size, let's say, in these kind of scientific libraries. And yeah, so now we have compiled it, but the compiled libraries or executables, I think this doesn't have executables, but they're still located inside the source, let's say, directory, source tree. They are still here. But if I want to have them installed, I can take advantage of, this is quite a standard. In lots of make files, this is, this is written like this. I have to call make install. And because I have already specified the prefix inside my home directory and I have write permission to that, I don't need to specify any other modifier like sudo. But if I didn't have it modified, then you have to run it with sudo because it tries to install it on system directories. Here I have nothing to do with this, so I type make install, and it starts to copy multiple things. And if I go one folder up, it should be here. You see that here I have GSL installed, and this isn't what I wanted to have. No, this is what. Yeah, you see that quite standard way, quite standard directory structure for this kind of libraries. You have bin, nothing very special, nothing very useful for us, and you have include, which is quite important. So I will show you why, and then we have the library. So these are indeed the compiled libraries, libgsl and libgsl.a and so. I don't want to go to the details of this sort of stuff, but this is indeed, sort of, let's say, this is indeed a dynamic library, and this is a, static library. If I want to go to the details of this, yeah, it might be a bit boring, but in the future, when we start to build programs, these are indeed the things that you need to know. But I think we will use this dynamic library, compiled dynamic library. But okay, this is pretty cool, but let's use it in action. So I go to directories, no, here maybe, just here inside GSL. I'm still here. I create a directory called test, and I want to test it out to see how it works. In order to see that, in order to see how it works, actually, we have to go to the reference, and I remember that it has a nice reference in a sort of a Redux format. So you can go through this. You'll see that there are the features for for scientific computing, for differential equations, for algebraic equations, and this kind of stuff are listed here. But what is really interesting for us at this moment is an example program. This example program is something simple that tries to compute the value of a Bessel function at 5. So this is indeed how it should be. This is indeed how a simple program that uses this GSL library looks like. So here I say, it. We can go for touch. We can call it Bessel, Bessel.c. And I can open it using my text editors, my text editor of choice. So where was it? It was here. So test. And I can open it with with Atom, or I can use it command line based editor. It doesn't matter. But yeah, this is the first time that we are using Atom. So yeah, this is indeed a source code, and you can see that it does nothing but if I bit. Now, the most crucial part is indeed this function that is tries to compute a Bessel function value of x, and the x is 5. But the important aspect, the important part of this file is this include. If we want to compile this program, we should tell the compiler where to look for this include with these header files. So I think it has the compile, also the compile instruction. Yeah, the compile instruction should be something like this. So let's have it here, and we have Bessel.c. So here, as you see, I described this in the previous videos. This C switch means that we want to compile it only. So we don't want to link it, and this is indeed better to help you understand a process. So I say GCC and all the warnings and compile only. I want just compile only, and this is indeed where we should ask the compiler. We should tell the compiler that okay, you have to look here for your let's see if it has autocomplete. Yeah, Tox writers, and it was GSL and GSL install. Sorry, GSL install, and then include. Let's have a look at that. You see that here it has GSL install include, and inside the include we had a GSL let's say folder, and in a source file it was GSL something. So if we set it to this include, it would automatically it fixes that, and you see that there are lots of header files here because I told you the library is indeed a huge one, a big one, that providing lots of functionality. So let's go back to our example. Here we see that we say that this is indeed, I think that this space is unnecessary. Compile only, and what file? Bessel.c. So we run the compiler, it runs very fast, and we see that we have Bessel.o, which is in sort of intermediate state for the files, because this is the object file. We have compiled it only, and we haven't we haven't linked it yet. For linking, we still use the GCC again, but this time we should use the switch L. So we say L, and then again the path to or let's say GSL install, and then here it is indeed the lib, and inside lib we have libgsl. Let's have a look at that. Here we have libgsl.so. So here, if I say that please with this switch L and then GSL, because when you specify L with its with its lowercase L, GSL, it looks for libgsl.a or .so, dynamic or static. It doesn't matter here. And also it has also GSL C++, which is indeed for a famous. This is something that is also compiled for us during the previous compilation process. This is the BLOS library, the famous linear algebra library that is released with this GSL library. So we specify that, and it is also here. You see this, and this is indeed this one. And plus, and then with this LM, which links the code to, let's say, to the CMass library. For CMass library, this is indeed M. And then we say that it was Bessel.o. Let's see what happens. Press enter. It says undefined reference to this, but we were specifying that. Maybe let's let me write it. Sometimes it happens we have to write it here, but there might be also some simple issues. So this is indeed Bessel.o. We have to specify it before the names of these libraries, and then we should have a out. You know how to change it, because in previous video I told you with switch O you can also change the name, but it doesn't matter. So here I run a out. Let me run it here, and very important stage. This is nice that it happened. So let me describe the difference between these dynamic libraries and static libraries. When you link your program against a sort of static library, that library will be part of your program, and that's why it's called static library. But for shared libraries or dynamic libraries, these SO files, these are very similar to DLL files in Windows. When you link them against this, what you have to do is indeed providing them at runtime, because these libraries are not part of the executable, part of the final output. So, sort of, there are lots of advantages for easier maintenance, let's say, or lower file size, this kind of stuff. But then, you should take care of this, that this kind of errors can happen, and you see that it is complaining about the lack of I cannot find this library in this shared library. So we have to provide it very similar to the way that we define path here. I think it is LD library path. Yeah, it is. And let's see if we have it. So we, there is nothing here, so we don't care if we override it. So here we have to say that it is indeed Tux Writers, and then GSL install, and then leap. So we specify that for linked libraries, for loading libraries, you have to look at this directory as well. And now we should be able to run A out, and you see that it computes the Bessel function value at 5. So you can add, if we want to continuously use this library, what we have to do is add this line to our bash rc. As I told you in previous videos, we have to add this to that file, and then we can always have this LD library path. And then this is indeed how you can use this. So that was pretty cool that also this happened, and then I told you about the differences between shared libraries and static library. So this is indeed how it works. You saw that now we have this compiled version of A out, and we have LD library path. So it can run, and this is indeed a way that you can use libraries like this. There are wide range of different libraries very similar to this, and you saw that it was super simple to compile and use that. So you can also try to go to the different sections, different features of this GSL library, and you just check it out and try it on your own machine. And you will find it that this is indeed pretty simple. So there is nothing to say to add to this video. So have fun with this, and see you later. Bye.